Okay, last video for this unit is going to be percent application and percent change. Okay, let's just jump on into our packet here. Okay, percent application. All right, and so you've got to make sure that you understand these different terms that could, because percent application or percentages can be applied to many everyday situations. You've got to be able to decode the various terms. All right, so we're going to take a look at these terms, and we're going to label the shopping bags as if it's an increase, we'll put an I, or a decrease to the original. So when you go to the grocery store or when you go to the mall, not that we can go either place is very good right now, the tax, when you are charged a tax, this is an increase. That makes it go up. When you have a sale price, is that making the price go up or down? Okay, that makes the price go down. Whoops, excuse me, I was supposed to put a D for decrease. All right, and how about if someone says, oh, you have $20 off or a certain amount of money off? That's D for decrease. Okay, and then what about a tip? When you add a tip, you're having an increase in what you have to pay. All right, gratuity, by the way, gratuity is the same thing as a tip. So you're increasing yours. Okay, and then when you have a markdown, that's a decrease. So that means that you are saving money. All right, so now what you've got to make sure, okay, that the key to solving percent problems in real life is to understand what information you are being given, what are you being given, and what are you looking for. Okay, what are you looking for? That's very important. Okay, so if you'll take a look at number one real quickly, and we see that Savannah works as a sales rep, and she receives. A sales rep means she's like a salesperson, right? Saleswoman. Maybe she's selling cell phones or cars. We don't know. Savannah works as a sales rep and receives $23.80 for every $140 she sells. What is her rate of commission? Okay, so what are we given? We are given. Okay, so what we're given, we have to go back a couple pages to know that, okay, we're trying to find this type of information. Percent over 100, part over whole. That's what we're looking for. Okay, and so Savannah works as a sales rep and gets $23 for every $140. So the given is the part. How much is the part? The part would be, okay, part would be $23.80. The whole, okay, is $140. What are we looking for? Okay, we're looking for her commission. Okay, which is actually the percentage. And a commission, what that means is that when a salesperson sells something, for example, if you went to buy a car, let's say you went and bought a cellular device, a cell phone, and you go to get a cell phone, and the new Apple iPhone 11 Pro Max costs $1,000. Well, when that person sells you a phone for $1,000, they actually get a commission. They get money, a certain percentage of that sale that you pay the store. They get some of that money because that's how they earn some of their money. Okay, so in this one, for example, we would actually have percent over 100 because we're trying to find that value, X percent equal part over whole. Okay, so then we're going to say X over 100 is equal to part, which is 23.80 over 140. Okay, and so now we're going to cross multiply. So when you cross multiply, you'll say X times 140. Okay, you'll say 140X is equal to 23.80 times 100. So that gives me 140X is equal to 2,380. This is something that you should know. If not, continue to work on that. Okay, and then when you divide both sides by 140, and I'm not going to do that work here, you find that X will be equal to 17%. That is the commission. That is the rate of commission. Okay, rate of commission is 17%. Okay, that's how you're applying that. So this section is talking about percent application. Okay. take a quick screenshot of this. This will help you if you want to real quick. Okay, and then here's a problem. Here's an example problem. Take a quick screenshot of that if you want to. Okay, now that's our percent application. So now we're going to look at a percent of change. We're trying to find a percent of change. Everyone, I know that you've seen this on TV or at the store when you go somewhere. Whenever they say, okay, we're going to have this big sale, 20% off of shoes, 20% off of t-shirts, 15% off of whatever, socks and all those things. So percent of change, okay, it describes the change over time by either an increase or decrease. It can be solved using a percent proportion in which the values are plugged into this formula. This is what's important. There's a new formula here. Okay? Percent over 100 equal change over original. Percent over 100 is change over original. This change can be represented by the difference between the new and original value. New and original. And we wrote this down before. Okay, remember ONC. We have original, new, and change. So you're going to write down the original value and new value, determine the change. But of these three values, we don't know what we have. So ONC. Okay, ONC is what you have to remember. And so this is going to be the most difficult portion for you to determine as well, is to write this value down. Okay, let's understand these pieces of the puzzle, because I'm comfortable that you know how to solve this problem. What I don't, or what I'm not sure of, is that you can set it up properly. Okay, we'll set some of these up. So if a gallon of milk costs $2.79 in 2000, and in 2015 it costs $3.98. Okay, what is the original price? So the original price is $2.79. Okay, now, or not now, but in 2015 it costs $3.98. What is the change? The change will be $3.98 minus $2.79. Okay, that's going to leave me with $1.19. This is our change. So now the percent proportion and the work. So percent over 100. Let's scroll up to the top and see. Change over original. Okay. Equal change over original. Once you determine these three values, original, new, and change, then you can solve these problems. So percent over 100 is equal to the change is 1.19. Original, 2.79. Okay. And now if we do some work, all right, when we do some work, we see that, remember that's an x there, we see that it's 2.79 times x is equal to 1.19 times 100. Okay, so 2.79x is equal to 119. So you divide both sides by 2.79. Okay, I'm not going to do all the work here, and I did not leave myself enough room, but x is equal to 42.6%. So that is an increase. Okay, that's an increase of 42.6%. Okay, I know I went through that fast, so take a moment to take a snapshot of that problem. I'm not going to solve the rest of these problems, but what I'm going to do is set up the rest of the problems. Look at the next question. If a frozen pizza costs $3 in 2000, and in 2015 it cost $2.50. So $3 is the original. The new is $2.50. So the change, okay, is 50 cents. So now you've got to set up percent over 100 equal change over original. There you go. Now you solve that problem. Okay, the third one, a movie ticket cost $8.20 in 2000, and in 2015 it cost $10.65. So the original is 8.20, the new one is 10.65. Okay, so then that means that our difference would be $2.45. So percent over 100 is equal to, okay, that is so change is 2.45 over original 8.20. There we go. Now you have proportions. Now solve the proportions using the previous method. This is how we determine our percent of change. Okay, take a quick snapshot of those. Okay, so there's other problems that you work on, but that's how you're going to work and solve all those problems. So if you have any issues or questions, please get back to me. Shoot me a text. Excuse me, not a text. A remind message is what I meant, not a text. Shoot me a remind message or email me, or you can send me a private message on Google Classroom. Okay, let me know if you've got any questions. Y'all take care.